Bismillahirrahmanirrahim and Assalamualaikum. My name is Mohamad Ilyas bin Ismail, 4th year of student FKMP. My matric number is AD170128. I will present about my final year project 2, which is water spray system as reducing negative effects of welding emissions. This is outline presentation. For the intro, I will cover background of study, problem statement, objective, scope of study. For the literature review, I will brief about local exhaust ventilation (LEV), welding emissions, and computational fluid dynamics, which is CFD. For methodology, I will explain about CFD by using ANSYS Fluent, meshing, and solution setup. In analysis, it is about volume fraction, velocity distribution, discussions about the result obtained, and validation. For conclusion, it will cover finding summary and recommendation. In chapter 1, it is about the introduction. Many small and medium enterprises have poor working conditions that cause safety and health problems for workers. Fundamentally, a prevalent example of engineering safety equipment used to control workers' exposure to chemicals that are harmful to health is the LEV system. In figure 1, it shows the basic components in LEV. In LEV, there is an air cleaner that has a filter in it to filter the harmful emissions. This study is conducted to obtain a suitable fluid pressure on nozzle via CFD simulation. For problem statement, it will cover about the effectiveness of water spray depends on the spray behavior produced by the nozzle. The nozzle that produce small droplets are more efficient because of their larger total surface area available for extraction. And indoor welding workshop have adequate air ventilation because it can prevent worker from inhaling welding fumes. This project will review the simulation of the water spray system for an air cleaner in local exhaust ventilation. The objective for my project is to conduct a simulation of water spray as a filter welding fume based on the effect of applying different liquid pressure by using computational fluid dynamics, which is ANSYS Fluent. There are 5 scopes of study. First, the model geometry was designed by using SolidWorks with specific dimensions. Second, ANSYS Fluent Fluid Flow as the CFD software. Third, 3 working fluid that used in this simulation, which is carbon monoxide, nitrogen oxide, and water liquid. Fourth, the pressure of the water liquid used is between 1 until 3 bar. Fifth, the analysis of volume fraction for all working fluid inside the filter box with the V6 nozzle. Move on to chapter 2, which is literature review. This is the important literature review that I use, which is first, guideline on occupational safety and health for design, inspection, testing, and examination of LEV system. Second, numerical simulation of welding fume lung dosimetry. And third, evaporative cooling by water spray system, which is CFD simulation, experimental validation, and sensitivity analysis. Next, in chapter 3, which is methodology, I will explain about CFD modeling process. The CFD modeling region could be classified into few major steps, which is pre-processing stage, model step, and solving, and followed by the post-processing stage. In pre-process stage, the geometry of CFD region was constructed and computational mesh generated in ANSYS Fluent. It is then followed by physical model, boundary condition, initial condition, and other appropriate parameters were defined, model step, and solving. Finally, the result could be obtained throughout the computational domain in the post-processing stage. Next is the phase of the design. First, about modeling, as you can see at the picture there. Second is transfer, which is import model directly from SolidWorks to ANSYS software. And third, simulation, using fluid flow fluent in ANSYS software and run simulation to determine the behavior of working fluid. As you can see in the figure, this is my flowchart. I will focus at the modify the parameter, because if I fail, I need to assign new constraint untuk the model, and if I success, I will proceed to compare and perform analysis on the results. The figure shows the name selection for the fluid domain. I assign for name selection for my model, which is inlet 1, inlet 2, outlet, and fluid domain. This two figure is about my meshing. The meshing value or element matrix observed was about 0.84, where an average of 0.75 provides a relatively good score. Statistical diagram reveals that tetrahedral, as you can see the red bar, give the number of element about 530,011 and 101,531 nodes. The lowest squareness of the mesh will be the exact calculation. This table shows my solution setup in ANSYS Fluent, and this table shows the boundary condition that I assigned for my model in solution setup. Okay, next, in chapter 4, I will show the result analysis discussions that I have done. This is my grid independent test, GIT. GIT with 101,531 nodes was selected to be the best mesh setup for filter box because the squareness of this mesh obtained the lowest, which is 0.83979. Hence, the mesh of this node is good, and the orthogonal quality is 0.99569, which is excellent according to mesh metric spectrum, as you can see at the figure below this. Okay, this table shows the contour of carbon monoxide volume fraction for pressure 1 bar until 3 bar at the inlet nozzle. The red color show the highest value of contour, while the blue color shows the lowest value of contour. The volume fraction of carbon monoxide in 2 bar pressure shows the low volume fraction contour at the bottom and outlet of the filter box, while the 1 bar and 3 bar pressure give the high value of volume fraction contour. Next, this is the volume fraction for nitrous oxide. The 1 bar pressure shows the low contour, but if compared to the value at the legends, 1 bar pressure has the higher number of volume fraction, which is 0.575. For 2 bar and 3 bar, they have the same value of maximum volume fraction, which is 0.483. But the contour at the outlet pipe shows that the 2 bar has the low value of volume fraction. And this is the volume fraction for water liquid. The 2 bar pressure gives the high volume fraction of water liquid compared to the 1 bar and 3 bar in this table. The volume fraction of water liquid for all pressure distributed at the bottom part of the filter box and outlet pipe. Next, I will explain about the analysis of velocity inside the filter box. For the top part inside the filter box, it can be observed that the high amount of vortex flow velocity produced at the 2 bar pressure of the inlet nozzle. The result shows that the 2 bar pressure at the inlet nozzle gives suitable water spray particle to this geometry model. It can be proven by the vortex movement flowing in a better circular motion and mixing with the other working fluid compared to the different pressure. This is the result for volume fraction at filter box with 1 bar pressure. The volume fraction of working fluid in this graph show the lowest volume fraction of water liquid compared to the others two graphs. This is for 2 bar pressure. The graph presents the highest volume fraction of water liquid and the lowest volume fraction for carbon monoxide and nitrogen oxide. This is for 3 bar pressure. The graph looks similar to 1 bar pressure because both figures shows the same nitrous oxide pattern, which is increasing at node number 5 until node number 10. Comparing all the three results, 2 bar pressure shows the decreasing volume fraction for the carbon monoxide and nitrogen oxide. It also gives the highest volume fraction of water liquid. The tuba is the most suitable for the V6 nozzle. It can be seen through the water liquid volume fraction, which is the tuba gives the most value of volume fraction. It means that the tuba has better water spray particle than other inlet pressure of the nozzle. Validation for this research, the simulation has computed average velocity at the outlet of selected line to compare with previous experimental results. The experimental velocity is same location as the velocity at the selected line in the simulation. The figure is about velocity distribution for zero bar. I select zero bar pressure because the design from previous study do not has filter box and water spray on it. I use percentage difference formula to compare the result from previous study, which is 2.71 meter per second velocity, to compare with my average velocity for zero bar that I calculated. The result come up with the percentage difference for zero bar is less than 10%. It is acceptable because the previous study for the LEV do not has a filter box on it, which is geometry model only shaped in cylinder pipe. Lastly, in chapter 5, I will conclude based on all the results and discussions that I have done. First, in this study, the simulation of water spray system as a filter welding film based on the effects of applying different liquid pressure is conducted successfully as the objective is fulfilled. Second, the results show that if the water liquid volume fraction is high, it can be reducing the volume fraction for welding fumes, which is carbon monoxide and nitrogen oxide. Third, the tuba inlet pressure for the V6 nozzle can be considered as the best as it gives good results compared to the other pressure as it offers the most volume fraction for water liquid inside the filter box and it more compatible with the dimension for V6 nozzles. Lastly, the percentage difference for average velocity was achieved as the validation and the result shows it below 10% of average velocity compared with previous study. As for the recommendation, first, propose better design for the filter box. Second is propose new dimension for the nozzles. Third, investigate the highest performing for the filter box with low cost production and estimation of the long life experience. Lastly, use high specification computer to run the analysis simulation. I think that's all from me. Thank you.